going to talk about one of the biggest challenges for large organizations that are doing software development at scale. Because maintaining a high code quality and consistent code base can become really challenging at scale. Let's say you have over 20 different teams throughout your organizations that are all doing software development. What happens in practice is that all of them are struggling with the same things. They're all fighting code quality, they're trying to reduce technical debt, and they're trying to establish best practices in their code base. And on top of that, they have to do these boring, repetitive tasks like implementing monitoring, metrics, exception handling, everything. And what happens is that all these 20 different teams have a slightly different implementation to this solution. And they all have to spend a lot of time on these 20 different implementations. So what if instead of having 20 different solutions, we would provide one centralized solution, one centralized approach to all these problems, such that all the teams can use that single solution. They get a lot of time to actually focus on implementing features and doing actual implementing business logic for your company. And as a result, the developer effectiveness and the developer velocity goes up. And I'm going to show you how we tackle this problem at Picnic. As he already mentioned, I'm a software engineer in the Java platform team at Picnic. Picnic is an online supermarket. Well, I bet you all know this cute vehicle that you see driving around most of your cities. And we're active in 3 different countries, namely the Netherlands, France and Germany. And we have about 2 million households as customer. So first I'm going to tell you a little story on to show you, maybe we should remove the balloons for... I'm going to tell you a little story to demonstrate why it is so important to have a centralized approach to solving problems. So who of you knows TestNG? Who has worked with TestNG? Okay, that's a good thing. Who of you has worked with JUnit? Okay, that's the answer I hoped for. 8 years ago, Picnic made the decision to start with TestNG as the main testing framework. Well, this appeared to be a mistake, and JUnit is the better, more innovative library to use. So then we decided, okay, we actually need to start migrating. But at that point in time, we already had 10,000 of these tests. And the idea was, okay, every team, please start migrating your TestNG code. Well, how does such a migration look like? Luckily, you know JUnit, so it's a bit easy. I have some simple examples. What we see is that we have the red is TestNG and the green is JUnit. So we have a class level annotation test, which means that all public methods in this class are a test. For example, this one. But instead of that, we have to annotate them all with the test annotation. And another one is, well, you know, parameterized tests. The equivalent of that is a data provider in TestNG. So we simply have to swap some annotations here and there, and there are a bit more, of course, but that holds for about 95% of the migration. Fairly simple, right? Well, what happened is that in practice, people have to implement actual business features. They don't have any time to fix this technical debt. So after a few years in which we were in migration, well, basically nothing happened. So then we started to think, okay, how can we do this? Because if a developer would go to his product owner and say, okay, I'm now done with the TestNG migration, I will do all 10,000 tests in our repository in the coming 2 weeks. Well, your product owner would simply be like this and say, are you crazy? We don't have the amount of time for that. You need to work on this important feature. So here we actually want to turn it around. And as a Java platform team, we said, hey, we have a nice summer intern bootcamp program. We had that back then. And we had an intern who actually worked on automating this migration. And within 2 months, we could actually provide a script that made it very easy for all the different teams to simply run the migration. They had to run it on a specific module or in their repository, tweak some things because it was not 100%, but 95+%. And then they could simply open a few PRs and it was a breeze to just do this. And this was the power of automation, because not all the different teams had to dive into this migration, but one person. That's a really powerful thing. So This is the agenda of today. First I'm going to give you a bit more context on the Java platform team. Then we're going to dive into some of the specifics that we provide as a platform, namely our centralized Maven configuration, a dive into how we do our dependency management, some of the shared libraries that we provide, and last but definitely not least, quite some tools that we use, static analysis tools and automation tools. So, our our tech team has around 300 engineers, of which half of them are Java engineers. We have 35 teams, of which there are 28 Java teams, and we have over 5 million lines of code, mostly consisting of Java, and Python is our other main supported language. We also have a Python platform team. So, what is our goal as a Java platform team? Well, we want to boost developer effectiveness. How do we do that? We have a few focus points. We want to ensure that the developers have a minimal overhead, such that they don't need to re-implement solutions and simply can focus on writing actual business logic. But still, there are many different domains in which these teams operate, and they know their domain best. So they need to be able to decide, how am I actually going to solve this problem? Which database am I going to use? We cannot dictate them, hey, this is everything you should use. They should still be autonomous to still make their own decisions. And that means that also the platform has to be all about openness. For 95% of the cases it should work out of the box, but they still need to be able to tweak behavior as they desire. Now I'm going to show you, that's one further. So let's say as a Java platform team we are responsible for the Picnic Java support modules. And besides that, we have many other repositories at Picnic. We have around 70 plus repositories. For example, the store, we have payments, parcels, warehouse management systems. There are many of them. But the cool thing is that all these different repositories declare the Picnic Java support modules as a parent project. Which means that if we add something there, some simple configuration for example, that it is available and inherited in all the other repositories. So they don't need to configure if we configure something. So the goal is really to put developers on top and make their lives easy by providing a foundation. As you can see, there are 3 pillars here, which are being the foundation, so the goals that we focus on to help the developers. One of them is we want to boost developer productivity. We want to provide building blocks that they can easily stack on top of each other and they can start writing their business logic. A cool thing about this is the multiplier effect. Let's say we are able to do to a repository we can do a 1% build improvement. It means that this will be inherited by all the 70 repositories. So actually it's a 70% improvement. So the improvements get multiplied. And I already mentioned convention over configuration. So for 95% of the cases, it should be the convention and people should not have to configure anything, but they still can if they want to. So another focus point is uniformity. We want to guide with coding standards and helping out with establishing best practices in the code bases. And we do this by having this centralized configuration setup. And we are a relatively small team that are supporting all the developers, so it's really important to leverage automation. So we have tools that help out with code quality, automatically reducing technical debt, and as the story I just told you, we also help out with migrations. And this is a slide where I show quite some images or some logos. The idea is that I want to show you that we support the developer throughout the whole developer workflow, from building, like actually writing code, committing to Git, having a Maven build, with a lot of developer tooling that help with static analysis and code quality gates, up until deploying and monitoring your applications. But today we're not going to dive into this part, we're going to dive into the first 2 parts. So, I would say without further ado, let's dive into the centralized Maven configuration. What does it mean? Well, there are basically 3 main topics in the Picnic Java support modules. That is the Maven parent POM, which consists of over 3,000 lines of code of all kinds of configuration. I will show you a few examples in a bit. There are the 40 shared libraries that all the developers, that all the repositories can start using, from the things I mentioned, monitoring, metrics, exception handling, but also things for Spring, databases. many things, and we provide a configuration for many of the tools that we use. And the cool thing is, they need to define only this piece of XML, and they get all these things out of the box. And there is no exception, all Java repositories at Picnic have this configured. So let's give some examples of configuration. A very important one, in my opinion, is the format Maven plugin. This basically formats your code automatically for you according to the Google Java format. And this again lives in the Picnic Java support modules, so all the repositories are formatted in the same way. Another one is the Maven license plugin. Especially for large organizations, this can be really convenient because it's hard to keep track of what licenses are being used where. Well, if there is a forbidden license that is being used, then this will directly fill your build and say, hey, transitively or either way, you are using a forbidden license. And so we have many plugins configured in the build, and by default they are all enabled. So if you run a Maven clean install, all the plugins will do their checks, and if there is any problem, it will fill the build. But of course, sometimes you want to run a quick build and just see, hey, does it compile? Then we also provide some convenience flags that easily tweaks the behavior of your build by using, for example, this flag. If you pass -d verification.skip, then all the plugins are disabled and you can simply compile your code quickly. And again, if you, in all the repositories, these convenience flags are the same. So if you switch teams, for example, you don't need to get used to what is specific to this repository. And then onto the dependency management. I shortened this section a little bit in the interest of time. But what we do at Picnic is, as a Java platform team, we maintain 200 of the core dependencies of Picnic. And we do all the dependency upgrades there. The idea is, which core dependencies? Well, for example, Jackson, Guava, Mongo, Spring, you name it. And the idea is that as a team, we build up a lot of in-depth knowledge of how these dependencies are used throughout Picnic. So if we see an upgrade, we know, okay, this repository uses it like that, and we can easily validate and check if it still works. And what you see as a result of this in-depth knowledge is that as a team, we on a regular basis actually file pull requests or GitHub issues in upstream repositories because we find fairly specific problems. And a nice tool, I already talked about a few people about this, but Renovate, we use Renovate to automatically open these pull requests. And it's a really nice tool for this. It assigns some reviewers. But also a very important feature is the auto merge feature. You can configure it that, for example, what we do is if there's a minor or a patch upgrade and all the checks are green, then it knows, okay, I see that everything is green. I can easily auto commit this and continue with your day. So still, we have 200 of the core dependencies in Picnic Java support modules, but that doesn't mean that other repositories still have quite some of these dependencies that they use. So still, we have about 1,500 dependency pull requests per month, and about 80% of that is being auto-merged. So that's quite significant. Something about our shared libraries. The idea is that every support module provides a standardized way following the best practices and is like a simple building block that with minimal configuration people can pull in and start using. So for example, for logging support, what is convenient is that if there is a problem and you don't know exactly in which service there is a problem, you can quite easily search through the logs because everything, the way we log things is really consistent across the entirety of Picnic. But we have many more that I already mentioned. And now I want to show you an example of how you can stack all these things on top of each other. Because let's say in your Spring Boot application, you can simply import the common app config, and as a result of that, you get all these things out of the box. So for example, the metrics config, the monitoring config, there's a Slack logging initializer and a web client config. And this allows you to easily plug all these things in. But besides these kind of things, we also provide some annotations that help you with, for example, testing. So let's say you want to, you have a Mongo repository that you want to test. What we provide is a custom annotation that is basically a wrapper around the test container annotation, and it helps a bit with automatically configuring some things for you, because every MongoDB connection across Picnic is similar. And what we do is in between tests clean up some extra state such that you don't need to take care of that. And a few months back I had the opportunity to go to a different team for a while, and so here I could actually start using what we were providing as a Java platform team. So it was interesting to be on that side. And what I saw, it was a greenfield application, so I started working on the main application, and the first thing I wrote was basically this. And so I started with the main application and I said, hey, I would like to have a Mongo config, a RabbitMQ config, REST config, Webflux app config, and a Webflux security config. And within 10 minutes I actually had quite some of these major technologies in my application, and I had to fill out a few properties, and that was basically it. So that's quite powerful that you can stack all these things on top of each other. So then the question is, okay, you have all these modules, and you have a lot of these dependencies in your Picnic Java support modules. Now onto the the releasing and making sure that everyone upgrades, because that's the next problem. Well, we have a fairly strict policy. We say that we support 2 major versions back. We do a monthly release, and we really urge people to upgrade as fast as possible. Well, you would always do that, but how do we ensure that people are actually able to do fast upgrades? Well, we have a fairly thorough validation process. So when we are about to release, we publish an alpha snapshot, and we want to make sure that this actually works and compiles in all repositories. So what we do is we have a script that actually checks out the repository, performs the upgrade, maybe some automated upgrades, some automated improvements as part of the upgrade, and then we just simply push the branch and check if Team City is happy with what we're doing, and if the build is failing, then we actually have to check out all the different repositories as a team and check, hey, what is happening here? Is there something that we missed, or is the new version actually working in all different repositories? As you can imagine, this can be quite a heavy process if there are a lot of things in the upgrade. But because we do this, we can make a stance on saying, hey, we only support 2 major versions, and you should be really fast with upgrading, because they basically only need to review the new changes and monitor if everything is still working correctly. So I would say that about 80% of the pull requests are merged within a week time. So that's quite nice. So then on to some of the static analysis tools that we use. But first, why do we actually have so many of these tools? Because we highly value consistency and simplicity. It's very clear that as a developer we are reading code a lot more than we are writing code, so we really need to optimize for the reading code and make it easy for ourselves. Because what our brain is actually doing when we are reading and reviewing code, we're basically pattern matching, like, hey, is this something which is similar to what we have seen before? Do we recognize this construct? And if something is slightly different, if you have a really consistent code base and something stands out, then it's easier to spot what is wrong. So we really focus on consistency. And in terms of reviewing, what we really want to get rid of are the small, simple comments that you can actually automate. Let me give you an example. Please use immutable list instead of empty list. Well, we think it's a good improvement because we heavily prefer immutables. But still, this is more or less like a stylistic issue that you want to solve automatically and not have to put a comment on the PR. The author has to incorporate the feedback, you have to check it again. that's simply a waste of time. Maybe even someone goes, comments something on this and there will be a discussion whether it's actually better or not. We don't want to have this, it's a simple waste of time. Another example is, hey, test methods should not be public. Make sure to add the final keyword. All simple things that we should automate. Well, a few tools. First examples, CheckStyle and Sonar Cloud. Static analysis tool that you can, for example, CheckStyle, you can enable quite some modules and you can even tweak them to your desired, I say that you can set some preferences in there, but they both flag issues for you. They don't automatically fix them for you though, so you need to do that manually. Another one that we are introducing, not every repository is using it yet, but that's the tool ArchUnit. It's a way with which you can specify, or I say that, which you can define rules about the architecture of your code. So more or less about the domain logic of your code. And you can do that with their nice Fluent API because it reads quite nicely. I will give you a very simple example of a logging convention. The idea is that, well, I can just say this as a sentence. Fields that have type logger should be private and should be static and should be final and should have name log, because everything should be consistent. So it's fairly easy to understand, and with one simple definition you can basically have this applied on your whole code base. A more complex example and a more on an architectural level is the following one. Classes that are in the logic module should only depend on classes that reside outside of API packages. Very powerful one, very powerful one. But this tool also doesn't automatically fix these violations for you, because that's where the next section goes about. So we already talked about the formatter. I think every code base should enforce the use of a formatter. Sometimes I hear the argument, yeah, if I introduce the formatter, then my whole Git history and Git blame is like cluttered with this one commit. Well, this cannot be an argument to not start using it, because there is a very simple git blame ignore refs file to which you can add the commit hash, and then it will not be taken into account with your commit history. So no arguments and no reasons. Another tool that we heavily use is called ErrorProne. ErrorProne is an open source static analysis tool for Java. It's created by Google. And this tool not only finds and detects bugs in your code, but it also automatically fixes them for you. And there are over 500 error-prone checks provided out of the box by Google. And internally we configured almost all of them. And as part of ErrorProne, they also ship a tool called Refaster. And Refaster is a templating DSL. And with this domain-specific language, you can specify refactorings using before and after templates. Let me show you an example. The idea is that it is really simple to specify refactorings. So what you see here is that we have a before template and an after template, and it's really about the content of the method body. So what we say is that we want to match these kind of expressions in the code base. And how this works is that when Refaster goes over your code, it matches any expression of type object and it will put it in here. And then it will check, hey, does it match this expression or that expression? And if it does, it automatically rewrites it to the content given in the after template. It's a very simple example, it's a code style thingy, but the idea is that instead of allowing 3 different ways of writing one and the same thing, we allow only one in our code base, and we also rewrite all the occurrences. So these literally never can occur in your code base again. Again, it's a simple example, but imagine you have many of these rules, your code base gets a lot more consistent. Well, we at Picnic were such a big fans of this tool that we started writing a lot of these rules internally, and a while ago we also open sourced this repository. So you can imagine that if you have 900 Refaster rules, that your code base gets a lot more consistent. And it's not only for code style things, but also to fix simple bugs, perform some migrations, help out with deprecations. Like there are many things that you can do with this. And we also have 40 error-prone checks, and well, based on the number, you can imagine that writing an error-prone check is a lot harder than writing a refaster rule. That's also the goal of a refaster rule, that it is very simple to do. Let me show you one example of a check that we have in error-prone, and that is the SLF4J log statement. So what we have is a log statement where we use %s, but that's not for this, so we need to use the curly bracket. And another thing that it will flag is, well, here we have a format string with one placeholder in which we can put something. Well, here we do that correctly, and here we don't provide it. Here we don't provide an argument, so it will say, hey, this doesn't work out. Please fix this. So then on to Open Rewrite. Open Rewrite is a very powerful tool that can do a large-scale refactoring. They have a concept called a recipe, and yeah, you can write any kind of recipes to refactor code, but not only. But this is also across multiple files, so you can do large migrations with this. Let me show you some examples. You can automatically migrate to Java 17, you can migrate to JUnit 5, you can migrate to Quarkus, and well, I highlighted this one already, the Spring Boot 2 to 3 migration. We also performed the migration, of course, and here we use the approach that we as a Java platform team took the effort of going through the Spring Boot 3 migration guide. For those of you who read it, you know it's a fairly long book. Here we don't want all the different teams to have to go through this one. So what we did is, well, we first performed the migration in the Picnic Java support modules, and then we started with to check if we could use tools like Open Rewrite and some other tools to make this to automate this migration. And as a result of that, we were actually able, with the team, to do this migration and migrated 3 million lines of code in 70 different repositories with a team of 5 developers in a few weeks' time. So that was quite a big achievement. Yeah, and one nice little news flash about the company behind Open Rewrite, which is called Modern. So I know one of the developers who works at Modern. His name is Tim de Beek, and they were quite interested in the refaster rules that we had in error-prone support. They were so interested that they actually started building a bridge between the error-prone support rules and their platform. And the idea is that they basically get a refaster rule, and with an annotation processor, they basically make it into a recipe, and then you can use that recipe to apply it with their platform. And well, I used it on some open source repositories, and well, then they indexed the repositories already. You could say, okay, give me these refaster rules, run it on these 1,000 or 2,000 repositories, and within a minute it shows you what changes it made. You click on, hey, commit this, and it actually commits it for you. So that's quite cool. Yeah, they don't support everything. They don't support all refaster rules yet, but they are actively working on this. And there was an arrow. So in this presentation, I showed you quite some examples. If you're interested in how you actually configure them in your Maven build, there's this QR code. It will also be probably upload a slide somewhere, and then you can check it out. And of course, I am not alone in the Java platform team, so I want you to briefly meet the fellowship of the Java platform team. And at the bottom left, we have the picnic logo to symbolize all the contributions that are coming from other people within the company, because we're still accepting contributions, of course. Yeah, and with that, we've come to my last slide. If you want to read more about Picnic, blog.picnic.nl. If you're interested in joining, join.picnic.app. But yeah, I would say that was it. Thank you all for listening.